Hi everyone, this video is an exercise 11I question 7 and we are given I, which is this integral, um, and that's e to the power of root 2x plus 1. So in part A we want to use the table to find the values of y, so that in part B we can use the trapezium rule to approximate the value of this integral. Okay, so for part A we just substitute these values, and the only thing is that it's better to stay consistent with the number of significant figures that they have used. So 0.5 gives us 4.1133, which there's not a bigger space here, so and then 1 simply gives us 5.6522, and 1.5 finally gives us what, 7.3891. Okay, now in parts we want to use the trapezium rule. So in trapezium rule we first find the value of h. So h is simply the upper limit of the integral minus the lower limit divided by the number of strips, and the number of the strips in this case is 6, because basically you can always just count how many x values you have, and then that minus one gives you the number of the strips. So in this case we have 6 strips, which is a half. Okay, now we use the formula of the trapezium rule, which is half h. So in this case both of them happen to be both, because this half is just a constant that always exists, and h is also a half. And now we just substitute. Remember that we substitute the first y value, so which is 2.7183, and then we also substitute the last y value, 14.0940, and then we do 2 times the y values in between. So we have 2 bracket 4.1133 plus 5.6522 plus 7.3891 plus 9.3565, and finally 11.5824. And this gives us 23.25. So that's our approximation of the area by trapezium rule. In part C, we want to use the substitution t is equal to root 2x plus 1 to show that I may be expressed as this form. All right, so first of all, remember that the integral is e to the power of 2x plus 1 dx. Okay, so now we are going to use this substitution that they have given us. So the substitution is t is equal to root 2x plus 1, which can be written as 2x plus 1 to the power of half. And now let's just differentiate this, which is a chain rule in this case. So we get half times 2 and then 2x plus 1 to the power of minus half, and this is equal to I forgot to use the correct notation here, so here becomes dt by dx. Yeah, and then dt by dx here is equal to 1 over root 2x plus 1. Now it's interesting because root 2x plus 1 is equal to t, so this is essentially the same as dt dx is equal to 1 over t, like this. And of course we need to rearrange this and make dx the subject, so dx is equal to t dt. Right, and also we need to transform the bound before we forget that. So when x is equal to 0, t is equal to 1, and when x is equal to 3, then t is equal to root 7. All right, so now we have everything. So here the limits are 1 and root 7. So we have e to the power of t times dx. Remember that dx is t dt. And this is exactly what we wanted to get, because this is in the form k. K in this case is just equal to 1, t, which we have e to the t dt, and then the bounds. All right, so finally in part D, we want to use the integration by parts to evaluate this integral and hence find the value of I corrected for significant figures. Okay, so now we just use integration by parts, and remember that in this case we set the we can start by setting the polynomial part, the algebraic part equal to u. So again, let's rewrite the integral. So we have I is equal to e to the t times t dt, and now let u be equal to t, so du by dt is just 1, and then dv by dt is e to the power of t, which means v is equal to e to the power of t. Okay, now we use the formula of integration by parts, which is basically uv minus the integral of du by dt times v in this case. So we'll have t times e to the power of t, and then don't forget to write the bounds, and then substitute inside. So inside we'll just have du by dt times et, which is just e to the power of t, which is just e to the power of t dt. And at this point we just have a very simple integration, because e to the power of t obviously integrates to e to the power of t again. And yeah, so we just now need to substitute the limits and just solve this. So root 7 substituted is root 7 e to the power root 7, and then minus simply e. And next, remember that again, e to the power of t just integrates to e to the power of t. So when we substitute root 7, we'll have e to the power of root 7, but remember that we have this negative, so it negates that, and the next term will be e to the power of t, and then we substitute 1, which is just e, but again we'll have this minus here, so minus that, basically that gives us positive e, because already that's going to be negative e to the power of t. So I'm just skipping this a step basically. So when you integrate, you get e to the power of t and you substitute this, so you'll have e to the power of root 7 minus e to the power of 1, but you already have this negative outside of this, so when you want to write as a total sum, then that negative affects these terms, and that becomes minus e to the power root 7 and then plus e. And yeah, so this is essentially what we get at the end, which is can be factorized to root 7 minus 1 e to the root 7, and this is when we approximate this by using calculator, this is equal to 23.2.